Awesome, man. So that's Luke with Southern Partners. He's our rep for South Carolina. So just real quick, Brent Jeffries, VP Field Operations, safety trainer and speaker for Brierer Meters. I've been with Brierer Meters for about 8 years. Walter Brierer is the owner of the company. He's my dad, my stepdad, but I call him my dad. He raised me since I was a wee lad. And my brother Joe Brierer works there. My sister works there. My nephew Ryan Brierer works there. So we're a family company. Walter has 17 patents, and so we have more patents than all of our competitors combined together. So that's kind of cool. And we're just a few hour drive up the road from you guys. So that's kind of cool too. It's not very often that I get a train in South Carolina, which is crazy, our own home state. We're out of Blythewood, so that's kind of where we're at. And we build these tools from scratch in our factory in Blythewood. We also have a live line training center that you all are welcome to use. Berkeley, you all can reserve it and use it anytime, once a year, once every other year, or whenever you like. So it's all live voltages, so we'll do the training, you guys kind of stand back, and eventually we're going to make it where it's hands-on, where you guys can participate. We've just got to make a couple of changes so it's a lot safer for you all when you come out to do that. And that's what we're working on now. But it's a really nice yard, overhead, underground, got a lot of components. We're going to add a lot more, maybe make I know Walter, he wants to make a mini substation as well. So we got a lot of things going on here in South Carolina. Walter's been in business for about 35 years, and he created a grounds tester that uses true continuous current. He made this about 35 years ago, and after 35 years of doing this, all this came to be, all right? So we do a lot with what we have with our little family company. Also, what we do is what you're going to get today. This is very unique to the industry. No one else does what you're about to get today, and it's called lineman safety and tool training. All right, it's something we do. I've been doing this for 6 years around the United States, all coast to coast. Been on both beaches in Canada, down to Brownsville, Texas, and even a little international. So we do this training everywhere. And for 6 years, we do the training. We haven't charged a penny for it, all right? I might take a dinner once in a while or a cold beer, but we haven't charged a penny for this training. It's all free. Brierer Meters, we spend about $1 million a year training safety around the country at no cost, okay? We're very fortunate to be able to do that. We give back. So with that said, as far as us coming out, like Luke was saying, we can come out and do stuff for you, field training with any tool or all the tools, or just talk, is we have this pamphlet. It's Brierer USA. It's utility support assistance, like on the front of that table topper right there. This here has nothing to do with anything that we're selling. This is everything we do for you all, our service that we provide all around the United States, okay? So that's what that's about. You guys can, remember, get a hat, pick a color, choose a hat. Later on, you gotta wait till after the end, Patrick said, so you guys don't slip out. And then we have line stickers. You guys, instead of getting one or two, like this morning, some of the guys in Johns Island, they took one or two. It's like, just take the whole sheet, okay? So I just don't give a sheet, okay? So anyways, we also, what's very unique about this company as far as the safety, we started about last February, we started what's really awesome, and you guys could get involved and participate and share. It's electric culture of safety. This idea came to me about a year ago, fell out of the sky on my lap, and it's like, okay, you guys start doing lineman safety national webinars. And, well, that's a good idea. So what I did is I met up with Incident Prevention Conference, the folks that speak there, the best safety trainers, directors in the United States, and speakers in the United States, they're consultants, Danny Rains, Jimmy Vaughn, and just all these great guys that have 40, 50 years of experience plus. And I said, look, I got this idea. It's electric culture of safety. I want you guys to come to South Carolina. Your company is going to pay for it. We'll pay for the videographer, but you guys are going to come for free, and you're going to share every single month. So we have monthly lineman safety national webinars every month, and here's a flyer. This is going to be Brandon Wiley with Northwest Lineman College. He's coming down. Lineman College, they're sponsoring it. And he's coming down, so you can catch on this. And once you're registered, you get all this announcements, all this, everything we do for free. There is no cost to anybody, okay? So it's very unique. We're bringing all the safety, all the line crews together as a line team. That's what we call it, a line team, all right? So it's pretty awesome. We have about 4,500 members that are registered as of now, less than a year, okay? So this is really cool. Anyways, so let's go over some safety. If you guys over here want to shift maybe just a wee bit, we're going to talk about grounds testing. Grounds tester. Can you hear me, Dave? Good? Okay. Y'all hear me well back there? We're good? Okay. All right, so we're going to talk about the grounds tester and your TPGs. Your TPGs are going to be considered one of your best friends. That's important to remember that. It's the OSHA 1910. We're going to go to 0.269, and we're going to go to lowercase, got to find it here, lowercase n. Lowercase n talks about your temporary protected grounds. And in here, if you read down, talks about it. It's a really good item to go over once in a while just to keep your minds fresh. But if you go down to number 4, lowercase triple I, talks about how the ASTM F855 and the, yeah, that's it, and the IEEE 1048 talks about how they are guidelines. It's in the regs that they're guidelines, all right? So you read about it, and it talks about how we want to, when we have our TPGs prior to use, this is really important information, by the way, guys, okay, is you want to always do a visual inspection. You want to complete a visual inspection, and you want to look for a lack of, an absence of smashed cable, crimped cable. Don't want to see any of that. Don't want to see any visual broken strands of your cable, or blackened cable, or patinaed cable. You don't want to see any of that, or bubbled jacket, all right? You don't want to see any obvious cracks in your clamps or loose components, and you don't want to see any oxidization on your components, especially the contact points. Then that's the visual, okay? So if your TPGs look good and they're lacking all those things, typically they're going to be great for you in the field. If they look good, they're going to do great. So that's what you're going to look for. Mechanical inspection. We want to go ahead and grab a hold of that clamp, make sure that clamp does not twist off the ferrule, spin off, make sure that the cable is nice and tight in the crimps of the ferrule. Make sure that cable is nice and tight, all right? Now, everything that we said we don't want to see, after traveling for 6 years doing this across the country, I have seen all that except the bubble jacket. I have seen everything you don't want to see. Some utilities I've seen right off the line trucks that they bring me their set, their TPGs. They bring them right off the line truck, says they never heard this before. Sir, this is like new stuff. It's a true story. And they'll bring them off, and I'm seeing broken strands, black copper, loose components. I mean, it's a mess. It's like, how old are these? You guys never inspected these? No, we didn't know. So that's a true story. So the cool news is that after I pack up this trailer and I drive away to somewhere else, another location, they change their work methods. They do. So you just got to, see, you guys need to understand that understanding is knowledge, all right? The why. Why are we doing these things? Okay, we got to talk about the why. And that's knowledge. Knowledge is safety. Is that correct? Knowledge is safety. So that's why I'm here. I'm here to share what I'm good at, which isn't too much, but at least this much, okay? So I'm going to share that with you, and thousands of linemen are much safer today than they were 6 years ago, and that makes me feel good. I'd rather be home with my wife. You know, she's not too far away. She is with me on this trip because we're in South Carolina, so this is a good trip for me, all right? But it's important that when you're out in the field that you guys understand these things and you watch out for each other. You're going to watch out for each other. You know, we got guys that go to the tattoo salon or whatever you call those places, and they say, I'm my brother's keeper. Or they'll say, I'm my brother's keeper with their mouth. And out in the field, that's not what they do. All right? So you could say, you could start a new website called I'm my brother's keeper and sister's keeper. Okay? You could do that. But it doesn't mean jack squat unless that's what you do. All right? So this safety thing that we're going to talk about today has to be a culture, has to be your consciousness, not just a bunch of talk. All right? It's what you do. So electrically test. Also, the guidelines talk about electrically testing. Walter Brierer, he made a tool that electrically tests using true continuous current. It's not a glorified ohms meter like some manufacturers. This is the real deal. He built this tool around page 2, table 1 in the ASTM F855 standards guidelines. Okay, so we're going to simply do an electrical test. I'm going to run this in parallel to mimic being used out in the field. When you use these, you're going to go from point A to point B. You'll have typically a little droopage because maybe they're just a little too long. That's fine. So we're going to mimic a parallel configuration, and this mitigates your magnetic field right here. This mitigates. So this is going to be in line and true to how you're using it out in the field. And so we're going to go to our tool, turn it on, and it requires a number 2 cable, which is this is a number 2, which is, to me, is way too small. You want to use a 1-aught or a 2-aught at least because they're not as flimsy. Okay? And what we're going to do is we're going to put 165 amps. There's an amp meter down here. Can you get this, David? You got that? Okay. Amp meter right there, and we're going to go to 165. And I can feel that current in my hand. And it feels kind of cool. Okay. We'll go about there. Okay. So we got about a little over 165, and we got a 0.228, so let's call it a 0.23 voltage drop. You go to the chart, it requires a 0.24 or less, so this passes. All right, and you can feel that continuous current. Like I said, it feels kind of cool. But anyways, the tool is very safe. You have very little voltage, so there's no shock potential, so I can touch it. Okay. So it's a very safe tool, and the safety that's in this tool, you'll see as we go further on that we put safety in all these tools similarly. All right. So the reason why we don't want to have, the reason why you don't want any coils, you want your TPGs to be in a straight line as possible, but you don't want coil. When you coil it up, that's like transformer, right? When you coil it up, that's where you're going to produce and create a magnetic field. So we're going to crank this up to 300 amps. You see that? And that current's feeling kind of robust right now. I like it. All right. Here we got a bottle. It's got a magnet in it. All right. So check out what happens. Here we go. Okay. You guys see that? A lot of activity. That's a magnetic field. That's not theory. That's reality. Huh? We're going to prove a lot of reality here today. You guys don't work with electrical theory. You work with electrical reality. All right, so that's what we're going to talk about. So if I go parallel, keep those amps exactly the way they are, and I go parallel, okay, same scenario, magnet in a bottle, watch what happens. Just a little hum, smoother, because we mitigated that magnetic field. So in other words, if you've got grounds, you don't want to leave them on the ground, coil them up so it looks all pretty. You don't want to do that. You want to string them out and run them out of your truck reel, your ground reel. You want to string them out and run them side by side to each other or in just a long fashion. That's how you want to use your grounds. Does that make sense? Okay, guys? True story. So we got a lot of safety videos. If you go to Brierer Meters YouTube channel, we got a lot of safety videos that you guys are able to access and use for free. Anytime you want. A year from now, we should have at least double on there because we're doing these electric culture of safety things, That's really cool. We got some good stuff already. And you guys can email me and ask for them, and you can have all those that we have to date and then get new ones as we go. Okay? A lot of safety, a lot of understanding, the why, a lot of knowledge, a lot of safety. Okay, that's off. All right, here's what we're going to do. We're going to talk about these voltage indicators, voltage detectors. The voltage detectors, voltage indicators work exactly the same as everybody else's. Ours are just more accurate, better, a lot safer. But I can't say that because we're talking about safety, all right? So I won't say it. So what we got here is we got a voltage indicator. Everybody's tools work exactly the same. If you ever use a horn and light, y'all have any horn and lights? Noisy maker or no? All right. If you have any horn and lights tools, or go to a utility or contractor that does, battery test. You want to see in here. It's real simple. That only tests the battery, does not test the tool, anybody's, on a live known voltage source. It just tests the 9-volt battery. It doesn't verify your tool is functioning properly at all. Just let you know the battery is functioning properly, and it's good. There is no transformer in here stepping up 9 volts to high voltage for a true tool functionality test. Several utilities I've been to, contractors, they were teaching their linemen that the battery test is a true tool functionality test. One this year, large utility this year. I left, they changed their work methods, okay? And that's good. So they know that it's not a true tool test now. All right, analog. You want to see that needle deflect all the way, like that, okay? You want to see it deflect all the way. If it's partial or it does not deflect, take off that quick change, tap out your battery, put a new one in that you know is good, and then retest. If you still get the same results, the tool's broken, you could drive it to our facility 2 hours from here. Drop it off or ship it. We'll fix it, okay? All right. So I'm going to do a battery test on a digital. Digital, what's cool about them, you have a PD800W, the wireless phasing voltmeter. It's a great tool. That PD800W, all you got to do, the battery test, is turn it, and it gives you the battery. Huh? How's that? What, 8.5? Okay? So you just simply, it gives you the battery voltage. That's kind of cool. All right? So it gives you more information. I prefer digitals because they give you more information. If you drop them, they don't have these moving parts like the analogs do. So the digital are more robust tools than the analog with moving parts. Okay? So, care. On care, you want to make sure your probes are clean. Hot stick wipes work great. No markings, no calibration stickers, no grease, no dirt. So that way you alleviate any exterior tracking to the tool, the components. The components that make the tools work, everybody's tools work, are conductive. They have to be, right? In order to give you a voltage indication when you're phasing or phase to ground or whatever, in order to do that, it must be energized to give you the voltage, right? Has to be energized. Well, it is. All right? So, how is it energized? Right here, you're touching primary at the tip of the tool. You're touching primary. We have resistors. There's a line limit here. If you look at your PD800W carefully, there's a line limit about 2.5 inches down. ASTM requires it about 2009. And that's just to remind you, okay, that's where the resistors are. And it reminds you not to bypass the resistors with a ground plane or with another hot phase. Does that make sense? Because this is your protection. So the resistors here protect the tool here and also protect you back here behind the tool. Okay? Not holding the tool, but on your stick. Okay? That makes sense? Pretty simple. All right? So watch that line limit. The line limit, what you're going to do in your mind, you're going to create an imaginary sphere. All right? You're going to take that line limit in your mind, and you're going to create an imaginary sphere around that tool, sides, the back, the top, all the way underneath. And that's going to be your air dielectric. We're going to talk about your air dielectric. She's your other best friend. All right? Always take care of your air dielectric. You're using these tools and you're encroaching in a tight vault and you have a cabinet door right next to the meter head. You could have an arc flash. The tool's energized, right? You got a cabinet here, it's a ground. You got a bleed wire. Maybe you're in a tight vault or a cabinet and you're going to go to your feed through and there's going to be a static wire or bleed wire near the meter head. That's a call we get more than any other call. We had an arc flash, your tool's no good. They show us a picture and it's like, well, keep the tool, but you need some lineman safety and tool training, lickety split. All right? That happens quite often. All right? From my understanding, talking with Mr. Patrick, you guys had one not too long ago with one of our tools, or somebody's tools, I don't know. And that's why, because there was a bleed wire, there was a cable that was near the housing, and they didn't know. See, typically when you all get a new phasing stick or get meters for testing, hot or not, typically you're handed the tools throughout the industry and no one teaches you how they function, how they work. You're just handed new tools. That's typical, all right? Okay, see you guys later. Have a great day, be safe. But no one ever taught you how the tools function. So here's how they function. And this equation is something you're going to carry with you the rest of your lives. And you're going to share this equation with other folks coming up alongside of you. Okay? And that equation is very simple. It's x plus y equals z. Okay? Just 3 little letters. X plus y equals z. All right? All right, I guess you could say A plus B equals C. I don't know why I choose X plus Y. I don't know. But anyways, that's what I did. So we're going to go X, that's your conductor. All right, that's your conductor. Energized or de-energized, don't matter. X is your conductor. Whatever you name your title, your conductor, that's your X. Okay? Then Y plus Y. Y is Y. How does a tool work? Why? How come? Y is tool functionality. This is how the tools function. Everybody's tool's the same. What they do when they make contact with a conductor and that conductor is energized is the tool looks at that capacitance, that current. It couples with the capacitance. It looks at the current in relation and looks at it in relation to the ground plane, wireless here. Looks at that current in relation to the ground plane and looks at that current and gives you a voltage indication. That's how they work. If the tool happens to be corded, like so, right here, you got the conductor and you got the secondary on ground, it's doing the exact same thing. X plus Y is functionality, but it's looking at the current in direct relation to the ground plane because it's corded. Wireless or corded, it works the same. Okay? All right, real simple. Equals. What does it equal? For all the time you've been working as a lineman, you thought it equaled the voltage, what it gave you, the information on the screen. That's not what it equals. Z is not that. Z equals, or I'm sorry, Z is, the meaning of Z is safety. Huh? That's the first thing that Z is meaning. It means safety and accurate information gathering. How's that? That's better. That sounds better than just some reading. All right? So, accurate information gathering, safety, and that's it. So, let's talk about that a little bit. We're not energized yet. Any questions yet? You all are welcome to ask questions. This is open forum. I'm going to ask you guys some questions, so it's only fair you guys can ask me questions. Okay? If you want to, just ask. All right. So when you're using these tools, it's important to understand, you know how these tools function. You know how they work now. It looks at the current in relation to the ground plane. So when you're using these tools, you don't want to use these tools ever by short sticking. You got your tool on your stick and you're short sticking. When we calibrate these tools, we don't calibrate these tools in our calibration room with somebody with gloves on, short sticking. We don't do that because the tools aren't designed for that. We stick them in the calibration room, and we're back off that stick as we calibrate it, okay? And that's how they're designed for you guys to use. You're not going to use them short sticking, because now the tool functionality, the tool is looking at you as the potential ground plane, not the ground plane. Your temporary bodies that you all are borrowing for a very short time, that's what it's looking at, all right? You don't want it to look at your temporary body, that ground plane, dirt and water. That's what your body is, right? So you don't want to do that. So you're going to want to train and teach that you're going to have some sort of a work method, depending on what you guys decide, where you're going to be back off that meter head a certain amount of inches. 31 is minimum because of arc flash. 31 is minimum. I recommend 36. Most utilities use 36. And that's what I recommend. Typically, I like to have a hand guard on the hot stick. And the reason why is because, one, you know that hand guard keeps your air dielectric. Right here. Visual, open air gap between you and the tool. All right, she's your best friend. Take care of her. But if I have a hand guard here, then, what's your name, sir? Robin. Robbie? Robbie? Okay, awesome, Robbie. Thank you. If I have a hand guard here, Robbie and I are out in the field, Robbie's going to automatically know that that hand guard denotes where my hands need to be behind. So he's watching out for me. If I'm short sticking, he's going to say, hey, Brent, get your hands behind that hand guard, buddy. Remember what we've been training. No short sticking. Right, Robbie? See? Some folks say, well, we don't have hand guards. We use electrical tape. Okay. That's an indication. I'm okay with whatever you guys decide. Okay? So no short sticking. Also, you don't want to ever tool glove. You got your gloves on. Here you are using a tool. Maybe you got some capacitive test points on those elbows, which you guys I don't think do have, but they're kind of cool to have. But you're using it tool gloving. This right here has never, tool gloving or short sticking has never equaled Z. Never has. In other words, it has never equaled safety nor accurate information gathering, short sticking or tool gloving. It's not safe, never was, and it's not accurate information gathering, okay? So we don't want to be tool gloving or short sticking. I had a lineman that's been a lineman for about 25 years, and he told me after everybody left, I was packing up, getting ready to leave. After everybody had left, he told me of this incident that took place that nobody on his line crew ever heard. He didn't want to share this. It's embarrassing, okay? And you all need to know, no one ever heard this from him. He couldn't share it. Why? He's afraid of retribution. Huh? He's afraid that if he speaks up and he declares something, that he's going to get in trouble. Maybe a spanking. But that's not how this is designed to do. If we have an incident, it should be safe for us to fail safely. You guys get that? There should not be any retribution. It should be safe to fail safely, because every one of us, every single day, makes a mistake. Huh? That's why they invented whiteout. They invented whiteout, so you made a mistake, you just white it out and forget it, move on. And that's what we need to do. If you make a mistake, let's talk about it so others learn, and be a warrior. Don't be afraid. Okay? Don't be afraid of, higher ups getting all pissed off. If they get mad at you because you are human and you made a mistake, maybe those guys need to get a different job, because they're not making it safe to fail safely. You see what I mean? So we need to just calm down and understand that every one of us makes mistakes, and let's share the incident. So he shared it with me, I'm sharing it with you. He went to the capacitive test point one time in his career, just one time in his career, without gloves on. He was tool gloving for 25 years, and one time he went to the capacitive test point, about 300 or 400 volts, and he went to that capacitive test point without gloves on. Now, you know how the tools work. You know current's flowing through it, and it's looking at that current in relation to the ground plane. So when he did that, what do you think happened to him that one time? What do you think happened? Yeah, he got popped. It scared him pretty bad, he said, but he got hit. Now, you guys know the tool functionality of everybody's tools, so for you, you're not surprised that that's exactly what happened, because electricity is not theory, it's your reality. You guys get this? And he got hit. But guys, he was very fortunate that he had a second chance. There's a lot of guys, when I do this traveling, I hear a lot of incidences that take place from other folks, because I'm in tune with the safety guys that do this, all right? And they tell me things, and I hear things, and it's pretty spooky how many things are going on that we don't hear about. And it's really sad. But you guys need to share what these things are. All right, so I get another call. Lead lineman, Northern Illinois, Cooperative Northern Illinois. And he calls me about 3 or 4 years ago, and he says, hey man, I'm using an analog tool, and I'm on 7200, and I'm getting about 13,000 volts, and your tool's no good. So I know if you're phasing 7200 and you're out of phase, you're going to get about 13,000 volts. You guys know that, right? That's what you're going to get. So I know that this guy that's calling me, lead lineman, the shepherd of Mr. Robbie, he's supposed to be the shepherd of Mr. Robbie. He's a living, breathing phasing meter out of phase. Because I know how he's getting at 13,000 volts. He's at a corner pole. He's got his back to the enemy, and he's short sticking in the bucket truck. So his body is coupling with the capacitance, here, the enemy. He can't see the enemy, his back's to it. And he's short sticking, and what's happened is he's coupling with the capacitance, it's flowing through his body, across his gloves, through the tool, the opposite direction to that conductor, and then that energized source he's making contact with over here is flowing through the tool this direction, this way. And so he's phase to phase, out of phase. True story. So instead of arguing with the lead lineman, I said, look, keep your tool. I'm going to get there, we're going to do some training indoors, and then we'll go outside in that same position, and let's use your broke tool and see how it works now. He's like, okay. So about a couple weeks later, I get to Illinois, and it's December, like here now. And in Illinois, in December, about 4 years ago, there was 8 inches of snow in the ground. That's not fun. But anyways, it was all right. Okay, so after the training, he gets in that same location in his bucket truck. Here's him and lead lineman in his bucket truck, back on his stick. Enemy is in front of him. He takes a broke tool, makes contact, and he's getting about 7,400 volts. So the tool was healed. Instantly healed. So when you're short sticking, this is improper body position. You got your back to the enemy. If at all possible, you don't need to put your back to the enemy or have your back to the enemy. You don't want your back to the enemy. So that's improper body position. Times 2. Short stick, back to the enemy, improper body position. After the training, he's back on his stick. He's facing his enemy in front of him, but he's further away from the enemy, and he's getting a great reading because he's not coupling with the capacitance over here at all. And the tool's functioning, you know how they function, properly. Proper body position. You guys get that? Okay. Another guy had a horn and light. Switch is open. He goes to the conductor. The horn and light's going off. The switch is open. How could that be? He's at a corner pole. He's in the bucket. Here we go. Short sticking. Back to the enemy. He's coupling with the capacitance here. It's flowing across him through the tool the opposite direction. Switch is open. He showed me the video. And he's getting a reading that conductor is energized and the switch is open. So was the conductor energized? Switch is open. confirmed, visual, right? But was that conductor energized? Was the tool functioning properly? Yeah, it was energized through him. It was energized through him. All right, so the tool was not lying when he said it was lying. He had improper body position. Okay, real quick. When you're using your phasing tools, corded or wireless, what you want to do is you got a vertical stack. I forgot this the last group. You got a vertical stack, so this is good. You guys are video. You want to come in at a perpendicular with your meter to that phase if at all possible. All right, perpendicular. Not only from perpendicular in relation to the other phases, lower and upper, but perpendicular to the long source itself. Okay, because you want a difference of potential, right? If you bring that tool parallel, then it becomes the same potential. Your readings won't be accurate. You guys get that? Okay, all right, so perpendicular. If you're on the top phase, you know, try to get it perpendicular. If you're hanging down from the ground and you got a little angle on it, that's fine. A little angle is fine, but try to get it perpendicular if possible. When you're working a horizontal stack, it's the same principles, but the only way you're going to understand it is if you got to turn your head like this. Okay? But it's the same principle. You guys ever see the little puppy trying to understand what you're saying? They turn their head. Then after a few months, they understand what you're saying. They don't do that no more. It's just at first they're thinking, man, this human is so crazy. He's saying these words. I don't even know what he's saying. They turn their head. Then after a few months, they understand. You're not too, just a little crazy, but they understand what you're saying. Okay? All right. Any questions thus far? You guys good? All right. You guys can ask questions. So what we're going to do is we're going to go ahead, make sure I got all that. We're going to go ahead and energize. So let me energize real quick. You want to get it? You want to get it, Patrick? All right. It's just the key. I think the switch is already up position.
Yeah, it is.
Okay. Thank you. You might just need a few seconds of choke on that little choke lever. Maybe. Okay, so we're going to energize the trailer. We're going to backfeed these pad mounts, and we're going to come out with 19.934.5, three-phase. That's what we're going to have here. We're going to have 122.08 here, and we've got some 7200 up here. All right? It's actually 122.08, but it sounds cooler if you call it 7200. All right? All right. So we've got the generator running. We're going to flip the switches. Actually need this chair over here so I don't forget something for right there. So what you guys are getting today, one of the speakers at ECOS, Billy Martin, man, this guy, he's about, how old is he? He's about 10 years older than me, whatever that means. But this guy, he's been a lineman for like 25 years. He's a registered nurse. He's trained in snow rescue, avalanche rescue, helicopter. He flies a helicopter, helicopter paramedic. This guy's really smart. He's done 2 of these videos for ECOS, 2 of them. And man, just listening to him is like sitting on a front porch with your grandpa and rocking in a chair and just listening to him talk. But he told me that what we're getting here is called tactical safety. That's what I've been doing. I didn't even know what it was. It's tactical. That's what he calls it. And then at the very end, I want to talk to you guys about psychological safety. Okay? And that's a very important subject, more so than I believe the tactical. All right. So what we got energized. So you guys have a PD800W. That's what this is. Wireless phasing voltmeter. The first part of the tactical safety is we're going to use your tool, this is your tool, for using it as a voltage indicator and going over a lot of safety. So your tool has a switch plate. It has degrees, DEG, degrees. And in that switch plate that has degrees, when you take your PD800W, put it in the degrees, that's when you're using it for one functionality, which is phasing. It's going to be looking at the phase angle. When you put it in degrees, it doesn't care about the potential. It doesn't care if you're on the high side, low side, transmission side, secondary side, underground, overhead. It doesn't care about nothing except the phase angle that Honda generation plant you hear is making. Okay, 3-phase. That's all. That's all it cares about. Now, when you're using it as a voltage indicator, which we're going to do now, you want to put it in URD, underground residential distribution, all right, if you're close to the ground plane. Remember how they work. We're the only manufacturer that does this. Nobody else does this because we know how the tools work. And we want the tools, when you're working underground, we want our tools to be more accurate for you. More information, more accuracy, more understanding, more knowledge equals safety. So that's what we do. We also have, your tool has an OH position, overhead. When you're using this tool overhead, put it in overhead, and it's going to be more accurate for you because now you're further from the ground plane. See how these tools work? Okay? All right. So capacitive test points, which you guys don't have, which are really cool to have. We're going to make direct contact. It's not very accurate under 1,000 volts, but it'll still tell us we're energized or not. It's not very accurate under 1,000 volts direct contact. We're going to call this an overhead line right here. All right? But I'll keep it in URD because we're still close to the ground plane. So we're going to go to this overhead line right here. We use a bushing adapter. Always use the proper accessories on your cone tip. Straight probe, hook probe, bushing adapter. If you're going to go to a feed through, bushing adapter. The reason why you always want to use the proper accessory is you want to protect the knowledge and understanding of what that line limit is about. And you're setting an example for others to always remember that as well. If you take a shortcut and do not use the proper accessory and just go straight off the cone tip, which you can do, all right, it's a shortcut. And what's happening is without that accessory, your depth perception is dark outside, foggy, your depth perception is not as good, and the opportunity to bypass that line limit is much greater without the proper accessory. So keep an eye on each other. Always use proper accessory. Okay? So we're going to go to this overhead line with the bushing adapter. Direct contact. If you all ever go to a utility that does not use direct contact tools or a contractor, you need to have a discussion with the safety guy, with the tool guy, all right, supervisor, and tell them to throw those tools away. Because if you have non-contact, and I've done this several times from utilities that had the mushroom or the potato smasher, it's always got to do with food when you're a lineman, all right, is right here, I'll get 69,000 volts. Not very accurate. Not making direct contact. You see, the reason why is because the tool is designed for the overhead. We're using it on underground, so we don't get accuracy at all. But if we're on an underbuild, all right, we're working this overhead line on an underbuild with a non-contact tool, how do you know there's no backfeed or induction for sure? How do you know for a fact? So our tools are designed to make contact with the X, okay? Direct contact. So we're getting about 20,000 volts, pretty accurate tool. When you're using your tools, you're always going to use it on a live known voltage source prior to use. You want to make sure the tool's functioning properly and is calibrated properly. So we're using a live known voltage source before we open the switch. Remember, the battery test doesn't test the tool functionality, okay? So we know our tool's working pretty good, about 20,000 volts, pretty accurate. You guys like that? Kind of cool. That's your tool, all right? So that's what you're going to do. So in OSHA 1910.269, again, you go to lowercase n, talking about your temporary protective grounds. Right here, elbow ground, cluster ground, whatever. When it talks about your grounds, go to number 5, and it tells you that before you install your TPGs, you're going to use your tester and verify an absence of nominal voltage, correct? Right? Absence. All right, that's what it says. But I believe those regs need to be changed. I believe that it needs to be changed to where you have an accurate tool, a good tool, which this one is, to verify not only an absence of your system voltage, but you're going to have a tool that's going to verify an absence of induction and or backfeed. Every single job, every single time. Guys are getting hurt on induction. Some die, okay? So non-contact tool, how are you going to verify those, a lack of those 3? When I was doing some training in, where was I? In New York. What's that town? Syracuse. I was in New York, and I was training with a contractor up there, and I did this thing about non-contact tools, not knowing that's what they used. So a couple weeks later, the safety guy calls me, he says, Brent, we heard your speech, and we know we can't use these non-contact tools anymore, so we're going to throw them all away like you said. And I used the word that I learned in South Carolina 8 years ago, and the word is called chunk it. I learned that. In Arizona, we didn't speak like that. And chunk it is one word, and it literally means throw it away. That's the Webster's dictionary for chunk it. Throw it away. And that's what they did, and now they're getting the direct contact tools like you guys already have. So they want to be safer, all right? So what it says in there, typically you're going to do open test ground. How I like to train it, I add a couple steps. The reason why I add a couple steps is the why, the knowledge. You get understanding, the why, equals safety. So we're going to add a couple steps. This is how I've been teaching it for a long time, and it's going across the industry, and it's just neat to see. Neat to hear the changes going on. So you're going to test first. Takes a little longer time instead of just going to the switch and opening the switch. We're going to test first because we want a live known voltage source. Here's our tool. It's working properly. Now we know that. That's important. That's good to know. But here's the biggest saying. When, hold on now. When Robbie and I are working together, the biggest reason why we're testing first is because Robbie is verifying my head's in the game. We got activity going on, man. We did the tailboard, we did our walk around, we compared notes, risks, trips, hazards. Hey, Robbie caught some things I didn't even think about. So we're comparing notes, we're writing these things down about this job site, all right? But does Robbie know my head's in the game? Do I know Robbie's head's in the game for sure, for sure? So we're going to have a little discussion about, hey, are you in this? Are you paying attention? You feel good, all right? Don't look good, but do you feel good? And we're going to have a little discussion, all right? And it's good to talk about it, guys. It's important. Robbie don't like me, I don't like him, but it's important to realize and know that his head's in the game for me, my head's in the game for him, all right? We got to know these things. So we do the test first. Then what we're going to do is we're going to de-energize. We're going to get some line clearance here, and we're going to lock out a little bit, maybe a little bit of tag out, and we're going to go ahead and retest, right? We got our visual confirmed air gap. We're going to retest. And the tool tells us, remember, we're looking for a lack of 3 voltages, types, sources, backfeed, induction, and nominal, your system. The tool says we have all 3 are absent. So now what we're going to do is we're going to test the tester on a live known voltage source. So here's a handheld power supply and test a tester, okay? So you are assured, make sure it's working. I did it once and the battery was dead. No, I did it once and there was no battery in it. And no one told me nothing. Okay, so I double check now. So you are assured that that tool was working properly on that conductor de-energized and all 3 voltage sources were not there. Your tool's good like that, okay? So now the 5th step is ground. Is that correct? That's the 5th step. So test, open, test a tester, ground. So here's what we're doing. We're taking a little more time to be a lot more safer. A little more time to be a lot more safer. More understanding, more knowledge equals safety. And Robbie, he's going to retire as a lineman when he's got a bunch of gray hair, or maybe no hair, I don't know. And he's going to retire and he's going to be safe. He's going to have all these kids. Right, Robbie? He's going to have all these kids and a great wife, and he's going to have her and the kids throughout his entire life because he lived safe. And whoever works with Robbie, they're going to have the same opportunity and the privilege as Robbie did because you guys are watching out for each other, and Robbie's going to be watching out for you guys. Does that make sense? So we just got to take a little more time. All right? We're lacking guys. We need maybe 5% more workforce. So we're always under the gun, we always have pressure, we always need to produce. And that's how us guys are. We always got to try to work hard, work fast, get production done. But that mindset is dangerous. It's very dangerous. So what we're going to do is we're going to calm it down a little bit and keep an eye on each other. And if someone's walking around too fast, making moves too fast, you just got to have a talk with them. Hey man, just chill down a little bit, bud. One less cup of coffee or something. All right, slow it down a little bit. And because a lot of guys are getting hurt because they got pressure on you to make production. All right, you got to make more hires. But if Robbie gets hurt, what happens? You're down 5% workforce because you're always behind. This place is growing. People love the Charleston area. All right, and so people are wanting to move here. So you're always behind the gun, always hurting for guys. But if you're down Robbie, then you're down 5% plus Robbie. You guys see how that works? And then it just compounds from there and it gets to be a bigger problem. All right. Any questions thus far? You guys good? Okay, I feel like I'm in a tennis match. I got to talk to you guys over here and then I got to talk to you guys over here. And it's hurting my neck. It's like a big tennis match. All right. I don't even like tennis, but it's okay. All right, so what we're going to talk about, there's going to be some situations, scenarios, where you're going to visually inspect your work area, and what's going to happen is you're going to see that if you use your phasing tool, your voltage indicator, corded or wireless, that you have an issue, you have a cabinet close by that you're going to have. You got a bleed wire that's close by. Maybe you're doing a substation, and if you use your tool and you make contact with the conductor, that there might be another hot phase nearby the meter head. You don't want to have that situation because it's the opportunity for an arc flash is very high. So you want to mitigate that possibility of an arc flash. So we got a 0 ohm extension right here. 0 ohm extension. You put on the 0 ohm extension and it's arc flash prevention. I think I'm the only one that came up with that. It's on a video. It's on a video. Okay. So what happens is you go from this scenario, you put the 0 ohm on, and then boom, you're in the clear. Isn't that cool? Very simple. A lot of utilities are going to the 0 ohm extension in their kits. They don't use them all the time, but when they get them, I don't get those calls no more saying, hey, your tool's no good, we had an arc flash. And then I got to look at the photo, then I got to drive out there or fly out there and do a training because they never had the training. Okay? And I'd rather be home. I really would. My wife is way prettier than you guys. She has a lot less hair too. All right, so let's got the 0 ohm extension. We're on an energized circuit, as you can clearly tell. Now you guys see those numbers there? They were closer to 20,000 volts before, weren't they? Now they're a little lower. So with the 0 ohm extension placed on the tool, you know how the tools function. So now that we have the 0 ohm extension on, the tool is now further from two things. I get to ask questions. Two things. The tool is further from two things. What two things are they? What's that? I'm sorry. Yep, further from the ground. You guys get that? Remember how they work. They look at the current in relation to the ground plane. Now it's further from the ground. The trailer, the cabinet, the bleed wire. All right, and it's also further from source. Further from the source. True, isn't it? Because you know how they work. See, that's easy. You guys got this. I was doing training in Tennessee, and the folks there, I don't think I talked about this morning, and that's a shame. I left this out, Patrick. I think. Maybe I didn't. So I was doing training in Tennessee, and what happened was two of the linemen, we were doing test, open, test the tester ground on that pad mount right there. It was about 5 years ago. The guys came up to me and said, hey, we had an incident take place. One of the linemen was working on hot elbows with his partner, and he was on a stick. They knew the elbows were hot, and he's working on that cabinet. And what happened was that cabinet was loose from its foundation. It's Tennessee, okay? So I don't know. It was loose from its foundation. The other guy had his gloves on, and he went to that cabinet with his gloved hand, and he put his glove on that cabinet, and what happened was he got arc flashed. Okay? It was a hot, sweaty, you know, he had swamp britches that day. Lots of water, lots of heat. Okay? So what happens is he got arc flash. He crossed a red line. He got burned up a little bit, spent time in the hospital. They said in the incident report the reason why he got arc flash because of rat piss in the cables. That's it. Book's closed. Rat piss in the cables, he got arc flash. How do you, okay, so an incident happens like that. How does any of the other crew members, how does anybody learn anything? The books are closed, rat piss, done. Was there any understanding of what really took place? And since there was no understanding, there was no knowledge shared, and there's no safety learned, right? So I got gloves on. I told those guys that story was a escape rat. All right? So you guys see those numbers? I got gloves on. Watch what happens to those numbers. What are they doing? They going up? Right? They're going up? But you know how electricity works. You understand how the tools work. You understand how electricity works. You understand that I'm a potential ground plane, and here I am. The tool is built this big, and now I'm telling the tool, you're this big plus me big. Is that what is happening there? Bigger tool. So it's a bigger bird on the line. So the bigger birds don't land on the line because they couple with the capacitance, the charging just enough to where they feel a shock, so they don't do that. The little birds make fun of the big birds because the little birds can do it. But the big birds can't. So don't be a big bird. Besides, he's got goofy feet anyways. Okay? So don't be that big bird. That's what happened. And every time you guys work out in the field energized, there are red lines. That's why you got mad. Right? Minimum approach distances. There's red lines. And depending on environmental conditions, depending on the equipment positions, depending on your proper body position or improper body position, those red lines fluctuate. They change. All right? If I take my gloves off and I touch this barehanded, I crossed the red line. Well, the gentleman, the lineman, when he put his gloved hand, what he was doing is he was trusting a good friend. And sometimes a good friend will let you down. Sometimes. And it did for him. He trusted a good friend, and what happened is when he put his gloved hand on that cabinet, he kicked the air dielectric, his best friend, to the wayside. You see what happened? Huh? And he might have been able to get away with that if it was a cool winter day that was a little dry like today. He might have been able to get away with that. He didn't have the swamp britches. Okay, he didn't have gators swimming around in his pants. He might have gotten away with it. Okay? All right. Mr. Robbie, you ready? I think that's a yes. All right, man. So you're going to use this tool here, right? So Robbie's going to use a PD25, and this tool is very accurate, plus or minus 1% true RMS voltage. We call it a multimeter because you can do so many things with it. You can high pot with it, you can phase sequence with it, de-energize capacitors, verify your regulator neutrals in the neutral position or not, phase with it, test lightning arresters with it. You can do a lot. We call it a multimeter. This is one of Walter's 17 patents. Okay, you ready? All right, let's go, Robbie. So Robbie, what I need you to do is you want to move in here, or you good? Okay, so kind of stand on the side so Mr. David can get this number on your tool. Let's see. Let's see if this works. It might not. Maybe not. Okay. I'll tell you what. Why don't you stand here? I'll see if this works. Okay. So what I'm going to do is I'm going to keep my air dielectric and I'm going to work safe. All right? And Robbie, if you could take a voltage reading on my boot, my back, second, and then my inside glove. I'll make a tunnel and go to my inside glove and read what the voltage is. All right, go ahead at 2 kV, secondary voltage. All right, good? All right. Make sure that Mr. David can see that screen. Point it at his level, parallel, same plane. There you go. All right, what you get? Tell them. No. Speak it to your crew.
13.
How much?
13.
Did you guys hear that?
15.
Huh? Say it louder.
15.
Go ahead. There you go. Okay? Yeah, say it louder. Say it to them. All right, now the back.
13.
Okay, good. Inside glove. Go ahead. Inside right here. Okay, drop that meter head. Can you see that, David? Okay.
12.
12? All right. So you guys see when I'm working safe. When you guys are working safe, you guys are coupling with your job. You guys see that? Measurably so. I got gloves on. I'm Gumby. All right. I'm all rubbered out. I got rubber sleeves. I got cover up. I got everything. But you still couple with your job measurably so. You still do. All right. Now what I'm going to do is I'm going to go ahead and short stick. The reason why I'm going to short stick, because I've been doing it a long time and no one's ever told me any different. I didn't know it was unsafe. I've been doing it for a couple of decades. Okay? All right, you ready? Same 3. Boot.
23.
Back.
25.
Inside glove. Get this one. There you go. Do you see that, David?
47.
47. Okay? So you see those numbers gone up a little bit. Now I'm going to tool glove. Remember that guy that I told you about in California? He was tool gloving for 25 years. One day he decides, I'm going to go ahead and tool glove, but he doesn't remember to wear his gloves. He gets popped, right? So I'm going to tool glove. All right, buddy. Same 3. 112?
Yeah. 150.
150? Inside glove. There you go.
128.
128. You guys see that? And I would not do this without the 0 ohm extension. I would not do it. So you can see it becomes unsafe. It's not safe at all. Does not equals, Z is not safety and not accurate information gathering. You saw that when I was bringing my hand to the meter head. That's not accurate information, all right? Okay, so real quick. Oh, I went to Georgia Power. Man, I'm getting old. I can't turn. I went to Georgia Power a couple years ago and did some safety training. And Georgia Power had some higher ups, safety guys. And they said, hey, I didn't do this earlier today either. They said, hey, we have these super dielectric overshoes. And they said, we bet if you wear these overshoes, those numbers won't go up with the overshoes, all right? So I told them, I said, look, I'll make a bet with you. If the numbers are similar, I get to keep your boots. That was 2 years ago. So let's see if they're this similar or not. Okay? All right, Robbie? Okay. Okay, ready? Okay. Going straight to short or tool gloving.
65. 95.
Inside glove.
125.
Okay. So numbers are similar. That's why I have the boots. All right. So what happens is I've got a super dielectric. Let me get through here. I got a super dielectric on my hands, super dielectric on my feet. So now I'm a capacitor. All right. And I've done this to where it was a misty day. We'd be outside, kind of misty, and every once in a while we would get several hundreds of volts on my back and gloves. I think one time it was about 1,000, 1,200. And the gentleman that was with me, when he touched my back, it actually made a little bit of an arc. So I had to tell him to hold that point of that tester tight to my skin so it didn't make an arc because it hurt a little bit. More scared. I was scared. All right. So anyways, but you see when it's moist outside, right? When it's moist outside, environmental changes, right? Conditions, environmental conditions, that's part of your tailboard. And that red line, when it's moist out, that red line comes at you closer and closer. All right? All right, let me take these off. I don't know if I get them off. Any questions thus far? All right. Okay, we're going to do some phasing now. If you all over there want to come, we're going to be more at this pad mount right here. Plus, it won't hurt my neck so bad. Okay, come on over here, Robbie. Okay, guys, so we're going to do some phasing. You guys could come in a little closer if you want. So we're at this address. And this address here that we're at is going to be called the left pad mount house. Okay, that's what Monk's Corner, left pad mount house. Robin and I are here, and when we phase, what the steps we're going to always take is we're always going to go phase to ground, obviously, to verify that we're energized prior to phasing. We're also going phase to ground first before we phase because we also want to verify the tool's working properly on a live known voltage source. Remember that. But we're also going to go phase to ground first because Robbie is making sure my head's in the game and we're going to talk about it. And I'm making sure his head's in the game, and we're going to talk about it. Okay, mutual accountability on the job site. We're going to talk about it. He's going to watch out for me. I'm watching out for him all job long. All right? We're not thinking about anything else except our job. We're getting paid for our job. All right? So we got to be safe. So go ahead, Robbie, read the reading on the capacitive test point right there, that little button. Right there. That's a capacitive test point.
365.
Get on this side so Mr. David can, there you go.
365.
Can you see that? Oh, good. All right, 365. All right, so keep that in your mind. Okay, go ahead to the next capacitive test point, the upper one. There you go. What you get?
279.
Okay, so we got a difference of about 100 volts more or less, give or take about 100 volts difference. So if we're phasing and we're in phase, what we're going to see is the difference. We're going to see the 100 volts, close to it. Do the subtraction, and that's where you get down to zero, the difference. Subtract the difference, you get close to zero, and then you're in phase. If we're out of phase, we would get close to, 500 volts. If we're out of phase, it's going to be way higher than the phase to ground reading off of any of those elbows. That means you're out of phase. You don't even need a calculator. All right, so I'm going to grab the secondary probe and go to the other side of this cabinet, and let's see if we're in phase or out of phase. Okay, go ahead to that top one.
75.
75, close to 100. Do the math, we're in phase. Very simple, very safe. All right, let's go ahead to this 12208 panel on the trailer wall. Just make contact, you ready? Okay, here we go. What you got?
118.
118, close to 120, stay there. What you got? Wait, oh, sorry. Okay, what you got?
93.
93? Really?
Jumping around.
Oh, it is, isn't it? Well, that's odd. Something's wrong. Stay right there. What you got?
205.
205, close to 208, out of phase, right? That's weird. Oh, go back to your lug. There you go. I don't think you're on your lug. There you go, jumping around. Stay there. There we go.
0.
0, in phase. See, the tool tells you something's wrong. And Robbie wasn't on the lug very well. That's the wrong part. So it's good. 0 in phase. Secondary voltage. Now we're going to phase these hot bushings right here. We'll call it overhead line. We're going to phase this. All right? Okay, come on. And what you're going to do, Robbie, is you're going to grab that bushing adapter that's on this cone. Okay? And what you're going to do is take off the straight probe, but turn back around. Turn back around, walk a few steps, and we're going to make the change here. So what we've done is we're going to make an accessory change off the cone tip. If you're making a tool change, equipment change, accessory change, or maybe Robbie's got to change his shorts, or maybe I got to change my shorts. What we're doing is we're disengaging from that energized field. We're walking a few steps away, and we're going to make the change a few steps away. Takes a little longer in your day to get the job done, but it's a lot safer. All right? Lot safer. It's intentional. Safety has to be in your consciousness. It has to be intentional. So you got to create that. You got to do that. And we're going to put on our bushing adapters. Mr. Luke, did you get a photo? Did you? Good. Awesome. Awesome. Okay, so what we're going to do is we're going to phase the ground. Okay, Robbie, go ahead to that top one. Plug it in, man. There you go. What you get?
1.
He gets 1. So what the tool is saying is that he was on secondary, He had it in the secondary position, but now we're on primary and he gets a 1. So the tool's telling him that he's got it in the wrong position, but it doesn't hurt the tool. So now go ahead and pull it and put it in 25. So he's going to go to the 25 kV selection. There you go. Now try it.
.202.
Okay, about 20,000 volts. So I'm going to go to the other side of the cabinet. Okay, what you get?
3.
3? All right, so it's about, what, 0.3? Does it say 0.3?
Yeah,
0.3. So there's a little bleed on that cable. Do you hear that? You hear it? There's a little bleed on that cable. If that cable right now was in wet grass, you would see a higher reading, maybe 0.6, because it would be wet grass. But here the concrete's pretty dry. There might be some steel, I'm thinking, in this concrete, because normally dry concrete, we're getting closer to 1 or 2 or even 0. So I'm thinking there's some steel in this concrete, all right? And you can hear that cable buzz. That cable right here, this cable, we're the only company in the world that builds a cable within a cable. Nobody else does this. So our corded tools, all of them, are shielded to 35,000 volts. So when we high pod or we phase using this tool, the cord can lay on the ground, but you want to stay away from that cord. It's part of the tool. Remember what we talked about, your air dielectric. So if yours are to stay 31 or 36 inches back from the meter head, you'll also want to train and teach that you're going to stay that same distance back away from the cord. Make sense? Because that's part of the tool. It's energized. You can hear that? See, Robbie says it's energized because he can hear it's energized. All right? So I got a call from a utility in Texas. And the utility in Texas, they had a couple guys that were working in a substation, a cooperative. And when they were using the corded tool, they were on a hot phase, and the meter head was close to another hot bus. So what do you think happened? They had an arc flash, right? And that's what happened. They called the shop and said, hey, your tool's no good. We need to get a replacement. Maybe we need to start using somebody else's tools. So they showed us the photo, and the photo showed, sure enough, the tool making contact. The hot bus is next to the meter head here, and the meter is like almost against it. So no one ever trained them on how their tools function. They didn't know. So they had an arc flash, and the guys, thank goodness, when they had that arc flash, it blew up at the meter probe, that interconnect cable here. Meter probe blew up. It blew up at the secondary probe, and the cord in between was all burnt in pieces and charbroiled. It was just disintegrated into black ugliness, okay? It was horrible, but they told me the story. Thank goodness they both came to me when I flew in to Texas. I did the training, and I met those two fellas, and they were able to talk to me. They were alive. They didn't lose no body parts. They had that one incident take place, but they had a second chance. And what we did is we talked about the incident. They didn't get in trouble, but we talked about it, how to mitigate, how to prevent these arc flash situations and scenarios, and the understanding and the knowledge to be safer. And we talked about it. All their crew was there. They had about 100 linemen. It was great. Brand new facility, and it was just beautiful conference room. And they told me the story that when it happened, they dropped their tools they were holding, they dropped them and went running, screaming like girls. All right? But a good thing they were able to run, right? They were safe. The reason why they were safe, they did one thing, improper tool position. That's improper tool position when you work like that. There's proper tool position, there's improper tool position, proper body position, improper body position. And it changes all day long depending on your equipment, the placement, and you. All right? So what they did is they trained their guys to stay 36 inches away from the cord. And when that arc flash took place, they were 36 inches away from the cord. So when they got hit with that arc flash, it didn't connect with them to ground. They were safe. They had the air dielectric, their best friend. And it was their best friend that day for sure. All right? So these things are happening. All right. Now, if you're phasing or if you're high potting, you always want to pull the secondary probe and go to ground first. Always. And Mr. Robbie, when he disconnects and he removes that off that hot bushing or that overhead line, he's going to see those numbers bleed off to 0, and he's going to recognize that it's going to take about 2 seconds. It's not instant. It takes about 2 seconds. All right, go ahead, Robbie. See what you see. Take about 2 seconds.
0.
Okay, 0. The reason why you want to always take the meter head off last is you want the meter to speak to you. When the meter speaks to you and you see zeros on that tool, then the meter is telling you that the tool is de-energized. Okay? So that's how we're going to do this all the time. You don't have to do that. You could go to the meter probe first off and then the secondary probe second off. You can. High potting, phasing, but because you understand and you have knowledge on how the tools function and work, you do it always the secondary probe first and then let the meter probe tell you something, information. Okay? So the reason why it took 2 seconds is because remember the resistors. It didn't bleed off immediately because the resistors are slowing that track out of the tool down just a little bit. So that's why it takes a couple seconds. Okay, good? Okay, you could turn that off and you can put your tool, like the secondary probe right there. And we're going to do some wireless. You doing all right, man?
Yep.
Okay, good. All right, so now we're going to do some wireless phasing. Mr. Robbie and I are going to do wireless phasing with your tool. Okay, the PD800W. So remember, when you're doing wireless phasing, you always want to take your tool and put it in the degree position. Not URD, not overhead, because we're not looking at potential, we're looking at phase angle. That's it. So you're going to take your reference probe that's hanging up there and your meter probe. Here, I'll get this ready. And your meter probe that's here, you want to always go DEG for degrees. I'll put this bushing. You can touch the capacitive test points with the bushing stuff. Just makes it a little faster. So Robbie's going to use the bushing adapter on the end of the cone tip, which is improper when you're going to capacitive test points or secondary voltages, because it's not a feed through or a hot bushing. It's improper, but it's still safe because it reminds you of that line limit, and we're keeping our distance from passing the line limit. Plus, we're saving a couple of seconds here by just using one accessory. Okay? Here you go, bud. All right, so the reference probe, we're going to go to an A phase. Now, you guys know that 3 phases come out of that generation plant. Your leading phase, that's your 0, whatever you choose it to be. Here we're referencing the A phase as our leading phase, so if Robbie touches any phase over here, regardless of potential, and it's an A phase, then it's the same phase. So we'll have a white light here if it's energized, and if it's the same phase, Mr. Robbie's going to see a white light on the meter, the PD800W. He's going to see a white light, and he's going to see the numbers, the LED display, saying close to 0. It could be a little under, it could be a little over, depending on leading and lagging power factors. It could be, but it's going to be close. So he'll get 2 confirmations that it's the same phase. If A is our reference, that's our 0. that means B is the next phase out of sequence. So B will be a blue light and 120 degrees. The C phase will be a red light and 240 degrees. So you got 0, 120, 240. You guys get all that, right? You guys understand that. Okay, that's how three-phase works. Boom, boom, boom. Okay, so I'll get the reference, and the reference probe will talk to your meter probe up to 300 feet away. All right? I'll put it in degrees, DEG. Verify we're energized. White light. So we're hot. Our A phase is hot. So Robbie, go ahead. Start at that capacitive test point at the very end. Go ahead to the top one. Go to the top. That way they can see it better. All right? So we've got close to 0. You see that, David? We got close to 0 and a white light. So it's the same phase. If you're in the field and you just want to match and you don't care about A, B, or C phase, when you see that, that's a match. Same phase. No phase angle difference. See how that works? All right? All right, go ahead, Robbie, go to that middle lug. There he goes. So we got a blue light, close to 120. So what phase is that? What phase is that one? It's the next phase out of sequence from A. What phase is it? B phase? B phase. See? All right. Go ahead to that right lug. There you go. Red light. Close to 240. Red light. What phase is that one? That's Spanish. It means yes. So he's right, see? He understands how to speak the lingo. All right, go ahead, Robbie. 20,000 volts. So Robbie was on 120. Now he's going to 20,000 volts. The tool doesn't care about potential. All right, so there's a B phase, right? 120, close to it. All right, come on over here. Capacitive test point. Okay, kind of make your body sideways. Can you see that? Can you see that? Okay, so that's your C phase. Careful. That's your C phase. All right, so now let's change this up a little bit. If I take the reference, and the only reference we have in this particular location is a B phase. If I take the reference and put it on the B phase is our reference phase, right? So B phase is our 0 now, not our A. B is our 0. So if B is our 0, everything now gets shifted, right? We go from A to B, so everything else gets shifted. So now C is 120, right? And A, come back around, A is your 240. See how that works? Because B is our reference, B is our 0. So it's B, C, A. 0, 120, 240. All right? So let's see if that's true. Okay? Energized, B phase. All right, buddy, you can touch whatever you want. You choose. Okay? Trying to get to a B phase, a reference phase. There you go. If you have trouble, I heard earlier at the last presentation that somebody was phasing a tight volt and the tool was getting confused with some other sources because it was a very tight volt. 0 ohm extension. Take that meter head away from those other sources. It'll do better for you. Okay? Okay? Still getting a little confused. Trying to say 180 out. Go ahead to your A phase. Let's see if it's an A phase. There you go. All right. All right. So there's your A phase. You guys see how this works? B's our reference. So the next in sequence is going to be a C, 120, and A is last, because we're looking at B coming out of the generation plant first. Our reference, that's our reference, okay? All right, good job. Okay, bud, you can turn that off and lay it, you can lay it right here. All right, awesome. All right, guys, we're gonna talk about a couple things, wrap this up. My voice is about to die, so it's probably good that we wrap this up. Mr. Luke, can you de-energize us? That generator? Just turn the key. That's good, that's all. Thank you. I think there's a cone on that door. I put a cone on that door. All right. Okay, guys, here we go. We're going to talk about a couple other things on phasing. So you guys have the PD800W as you saw it work. You already have that. But you can take it to a new level. So in other words, all you got to do is get one base unit in your entire system for all 4 service centers, one base. You simply plug it in to the wall socket here, substation, that's usually typical, or your house. And what you're going to do is you're going to calibrate this unit. It's really simple. You got dip switches back here to calibrate it with. That when you take your PD800W and you touch a known A phase, you're going to get zeros. Once you get zeros on a known A phase, this is calibrated. And B will be 120, a blue light. C will be 240, a red light, once you calibrate it to an A phase. See how that works? It's real easy. Once you do that, you don't have to ever think about this device. It's got up to 5 phone lines. So 5 linemen can use this at the same time, one base unit, 5 linemen, and that'll probably never happen in your system. Maybe 2 or 3 once in a while, but not 5. But you can put 5 phone lines into one base, and then what you guys are going to do is you're going to have one field unit at each service center that somebody can sign out for it. That one field unit is what you take with you. And you take it out in the field, you get to your location, you take your cell phone, you make a call to the base. And you'll hear in your earpiece, you'll hear the grid data, beep, 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 like that. All right? And then you simply turn on your Bluetooth. When you turn on the Bluetooth, it links up to here, your field unit, and when it does, the white light, there's a white light here that goes solid. When the white light is solid, this becomes your A phase. This is your A phase reference anywhere in the field. So when you're phasing, all you need to do is be within 300 feet of this antenna and this antenna. And whatever conductor you touch, potential, don't care about. Whatever conductor you touch, if you get a white light and close to zeros or 0, then that's in what phase? A phase, right? Same phase. Because A is your reference. This is A phase. It's white light, solid. This is your A phase reference. So you get zeros in a white light, then that's your A phase. You touch any conductor, any height, any span, any dimension, any name, any title, and you get a blue light 120 or close to 120, that's going to be your B phase. Red light 240, C phase. It's real simple. It's that fast too. It's very accurate. I started telling Patrick a story today, and I got sidetracked. I didn't finish the story. But I did some training in the Cayman Islands, and I brought my PD800W kit for the training. We did about an hour and a half indoors, and we did about an hour outside. And what they did is they have red, white, and blue. So they're kind of patriotic, kind of American. But they got red, white, and blue for their, not ABC, red, white, and blue. So what they did is they took their reference probe outside, and they hung it on their white. And then they took the meter overhead. They took the meter probe, they went in some underground capacitive test points. They went underground, and they made contact, and the red and blue phases, they never knew. They had no clue. That's blue, clue, never knew. Anyways, that the red and the blue were repositioned. They were swapped, all right? They didn't know that. And if you go to like Jamaica and those islands, they have a kind of an accent. Hey man, what up, man? They try to talk Jamaican. And when they saw that happen, they're like, whoa, man. It took about 60 seconds to discover, took 60 seconds. I got it on video, 1 minute exactly, to realize that the red and the blue were swapped. And you should have heard them going off. They had no clue. And the tape was completely wrong. It was all wrong. They didn't know. They like that. Anyways, real quick, high potter. This is a high pot tool, and you can use this quickly on new construction or existing to verify if the span between transformer is good or bad. And you simply use an 18-volt Milwaukee or Makita, turn it on. You got a feed through, you got your primary isolated, de-energized, and you just plug it in that feed through, turn it on. You got it on your hot stick, turn it on, and the needle goes up, charges that cable. If the cable's good, the needle comes down within a few seconds and stays down, the cable's good. If the needle goes up, stays up, or it bounces, then the cable's bad. If the needle goes up and stays at maybe 20% and hangs at 20%, it's just telling you you have some bleed on the cable, it's an old cable, and it's a long run. But it's fine. The cable's still fine. All right? So this is just a very safe, easy tool to use, efficient. You don't have to have an AC source. Very safe and quick. All right. We also have the ST800. You guys are bringing this into your system. This tool here is amazing. Troubleshooting. You all do troubleshooting, partial power, flickering lights, right? Couple? All right. So this is a great tool. This tool here, it sources up to 800 amps, hence ST800. So it sources 10 times more load than anybody else's device. So this is a great tool. And what you do is you simply take it, you've got a, inside that trailer, I don't know if you guys could see it. Some of you won't be able to because that wall's in the way. But we've got a right bottom home, and there's a ST800 hanging on that can. There's a magnet on the back. Ferrous material, sticks right to it. And what you do is you pull the meter, you go to the lugs of that meter, or the meter jaws, you go to those, and you go, secondary is energized, you go hot leg 1 to neutral. Turn the tool on, and you look at your voltage. And in this particular case, we're seeing about 100 volts. So obviously one of those legs, hot leg 1 or neutral, are bad. And the tool's already telling you that. Then you're going to toggle from the voltage, toggle to the load, and it's going to sequence the count. You're going to see the count, and you're going to see the load climb up. But because you saw 100 volts, you know that the load climb up is going to be very slow because the integrity is bad. Sure enough, you're seeing a 2 amp jumps each count. So it sequences the count on the screen to the load here. It gets up to 40 amps, falls on its face, and starts recounting. And you got a splice, or you got a lot of lift poles, and you hear a popping sound over the yonder. So the tool's already, because it's in the clear, the tool's already found the issue for you. So what we're going to do is continue the testing. We're going to find out which leg it is. We don't know yet. Hot leg 1 or neutral, we don't know. So what you're going to do is you're going to go ahead, turn the tool off. You're going to take your red lead, and you're going to go to hot leg 2. Turn the tool back on, look at the voltage. Well, we're seeing 100 volts. Again, so now the common denominator is you got a neutral issue. Turn it on, go up to the load, and you expect to see slow counts. And you expect, because it's the same situation, that it's going to get up to about 40 amps, fall on its face, recount, you're going to hear popping. Sure enough, it happens. Turn the tool off, we're going to go in phase, hot leg, I'm getting all tangled up here. Hot leg 1 to hot leg 2, in phase. Turn the tool on, look at your voltage. You're seeing 240. You're hoping you're going to see, when you go to the load, you're hoping to see those counts jump up fast and furious, because you're hoping, you saw 240, you're hoping that the integrity on both legs is good. Sure enough, you turn it on, and it goes to the load, and you're seeing 14 or 16, maybe 12 amp counts or jumps per count. Gets up to about 800 amps, stops counting, holds, those two legs are good. You're done. Now we're going to find that issue on the neutral, retest it, discover it, turn it off, go ahead and make your repair, and then you're going to retest. And the reason why you retest is because this tool sources 800 amps. You can find a problem in that circuit prior to the customer recalling you back out 2 or 3 years later, telling you that they got another problem. You're going to be proactive. You might have a problem that takes 300 amps to find. Okay, so you do, and you make that repair. And then you go back, retest it. And this time it goes to 800 and it holds. So that circuit is now good. And that's not uncommon because now you're sourcing more load. Where the other tool, you make your repair because it's only 80 amps, and that secondary problem you won't find because you don't have enough. You got to wait until they call you. So now you're wasting more time. More time out in the field is higher risk is less safe, more expensive, right? Wouldn't you guys rather be here talking to John instead of getting called out to that lady? Her dog is mean anyways, all right? It took a chunk out of your britches last time you were there. You don't want to go back. Okay. That's the first function. The secondary function is we got a STRCV, that a service test receiver, STRCV. This goes together with the kit or separate, but with this tool you can now identify your secondaries at that pad mount. If you want to pull a particular customer off service so you can do some work and keep all the other customers on, this picks up the pulse, and now you can go ahead and isolate that customer and re-tag those cables because there's no tags on them, or you can't read the label any longer. So now we can identify your secondaries. You can also use this to identify positively your feed in and feed out at the pad mount. You can also use it to ID your primary cable energized or de-energized. 5 functions. Pretty cool. All right, real quick, we're almost done. I'm going to talk some psychological safety. We've got a 3-phase ID. We got a single phase ID. I'm going to skip the single and go straight to the 3 because it does what the single does times 3. It give you A, B, or C, de-energized primary cable, and it goes through about 2 to 3 splices. After 3, it loses too much of the load, the pulse, and you can't read no more. But up to 3, it does good. All right, so we got a CT clamp. All the lights are hot. We got continuity. We have a path back to the tool through the ground. Concentrics are good. All right, so we get 1 pulse. You see in here, that's an A phase. Go to the next cable. Two pulses, that's a B phase. And then you guys probably figured out this next one. There you go. 3 pulses, that's a C phase. Very safe, easy to use, all right? All right, and you guys could trial any tool for 30, 60 days, no cost. If you like it, great. If you don't, that's fine. All right, now I want to talk to you guys about psychological safety. Can you guys move in just a little bit? I'm starting to lose my voice. It's almost beer 30. It kind of heals the voice after talking. So anyways, so I've been doing a lot of this training throughout the country, and the things that I find out more and more why guys are getting hurt is not necessarily a lack of safety and safety training. That's not why the majority of these incidences are taking place. What I hear from all these incidences, the reason why folks are losing arms, the reason why somebody loses a hand, someone loses a leg, the biggest or they don't go home no more. That's it. They're done. All right? We're gonna go ahead and prime our practice, and we're gonna practice putting our bucket trucks together with flags hanging down. Who wants to practice that? Huh? I don't want to practice that, ever. So let's just stop. That's just such a waste of time, putting somebody in the ground. Okay, we got a work to do, so let's not put people in the ground or feel sorry for somebody because now their arm is gone. I don't want to feel sorry for someone because their arm is gone. I want to spend time with the people so their arms don't disappear. and we watch each other. All right? So it's important that we connect. It's important that we communicate. It's important that we're committed. It's important that we are accountable. So if I'm with Robbie, I'm going to work with Robbie this day, and we're going out in the field, and he finds out through our conversations that I was all night partying with my friends that I haven't seen from Arizona in a long time. And I'm a journeyman lineman. Robbie's been here 14 months. Robbie has every right in the world to turn that truck around and head me back to the shop, and I go home for the day. He has every right in the world. And the reason why is because prior to me showing up to the job site, I was not personally accountable to whoever I was going to work with that next day. I did not prepare myself personally. I was not personally accountable. I shouldn't be there. All right? So if you ever do that, you better call in sick. Because if you do that and you show up to work, you're not being personally accountable to anybody around you on your crew. And that's horrible. This is why guys are getting hurt. Another thing that's happening is that when they're on the job site, that we're not mutually accountable. In other words, Robbie's looking out for me, I'm looking out for him. All right? We got to look out for each other. Mutually accountable personally, before the job, on the job, mutually accountable. Several years ago, there was a couple guys working hot, and they were changing out a broke pole. And what happened is 20-year journeyman lineman. And what happened is one guy was pulling the log out of the trailer with the boom. And they knew they were working hot. There was no secret. They knew that. And at the same time, one lineman was pulling out the log. The boom hit the energized circuit. At the same time, the other guy was in the truck pulling out gear. Same time. 20-year journeyman lineman smoked. Kids, no more dad. Wife, no more husband. That's it. Gone. The mom and dad, no more son. Is gone. Just that quick. There's no coming back. So what happened was the guy that was working the boom, was he mutually accountable? Was he mutually accountable for the gentleman that got smoked that was in the truck? Was he mutually accountable on that job, that moment, that day? Was he? No. Okay? Now think about this. His buddy that was working the boom, friends, all right, fellow lineman for some time, working the boom, and he goes in the truck. Was he mutually accountable to his buddy that was working the boom? Do you think he would want that weight on his friend's shoulder the rest of his life while he went with his kids, saw them graduate, saw them going to the prom, saw them doing this and get married and doing all this stuff, going out to dinner? Do you think he would want that weight on his shoulders, the guy in the boom, and he smoked? See, he wasn't being mutually accountable either. See, it goes both ways. There's 4 steps of psychological safety. And the first step, and this is super important, these 4 steps, all of them are very important. The first step of psychological safety is that you've got to make it safe here, Berkeley Electric Cooperative. You've got to make it safe to be included. Okay? Robbie don't like me. I smell. I don't take enough showers maybe. Maybe I talk foul. Maybe he doesn't, I do. He don't like that. All right? But when you're a lineman, you make a vow. You sign an oath right here. You sign an oath as a lineman, and that oath is unbreakable. And that oath says that regardless, if you don't like me or not, you're still going to connect with me on the job site, and you're still going to connect to me, and you're still going to watch over me as my brother's keeper, my sister's keeper, all right? You're still going to watch over me. Even though Mr. Robbie don't like me, I don't even like him, okay? But I have an oath to him, and I'm going to watch out for him because that's my job. That's what we do, linemen, okay? So it's got to be safe to be included, all right? Maybe Robbie has he speaks a little weird accent from Canada or something, hey? But I don't like him because he's from Canada. Stupid reason, but that's the truth. I don't like it because he's from Canada. I still got to make it safe for him to be included on this crew, right? You also got to make it safe to learn. Robbie's been here for 14 years. We'll multiply that, or his 14 months times 12. He's been here for 14 years. I just started. I don't know dip squat from nothing in line work. All right? I'm on the ground, man. I barely know anything about the groundwork. I could barely use a shovel. But I decided in my heart of hearts that I want to start working hard in my life, and I'm tired of playing video games. All right? I want calluses. What are they? I don't know. But I want them. But see, it's got to be safe for Robbie to allow me to learn. You guys got to make it safe. For me to learn, I got to make it safe for you all to learn. Okay? I don't know as much as you guys. Maybe you guys don't know much as the other guy. But it don't matter. Maybe someone's a little slower at learning. Maybe someone's a little quicker at learning. None of that matters. None of those differences make a difference in safety. Okay? Also, the third step, you guys got to make it safe for me to speak up. I got to make it safe for you to speak up. We're all on equal plane. Mr. Patrick's got an issue with me. I got to make it safe for him to speak up, talk to me. If I got an issue with the CEO of Berkeley Electric Cooperative regarding safety, that CEO must make it safe for me to speak up as a ground man. Safety is not about who the safety guy is. The safety guy is simply a coach for safety, coaching the team along. But the quarterback, the linebacker, the center, all the defensive, all the offensive linemen, all the positions, the receiver, all of them are thinking safety equally. The safety guy is simply a coach that's coaching the team along. But the team is thinking safety just the same as the coach. You guys get this? That's how the team wins. That's how no one gets hurt. That's how everybody gets home. So you got to make it safe for Mr. Robbie to speak up. All right? You also got to make it safe, and this is super important, for somebody to challenge. If someone has a challenge, it's got to be safe for them to challenge the status quo. Same thing, hey, I've been doing this for a long time. Son, don't be telling me how to do my work. Do you think if Robbie's talked like that, do you think if he sees something, you're up in the air, and he sees something that's sketchy, do you think he's going to want to speak up? Because you're not making it safe for him to speak against the status quo? Do you think he'll be less prone to say something when he sees something now at this point? Because you didn't make it safe for him to challenge the status quo? You don't have to like anybody's idea. Everybody in the room you talk with, you see the heads go like this. And there's one guy that goes like this. Okay? You got a book full of matches. All the match heads are like this. One lights. They all eventually catch on fire. But you got one match that says, I don't think this is right. I don't feel right. I got a gut feeling. When someone says, I don't think so. When someone says, I don't know. When someone says, I'm not quite sure. That's the match that's coming out of the line protecting these other matches. Huh? All right? See how this works? So whenever somebody says, I'm not sure, I don't know, that seems sketchy, listen to them. Why? And what they say, you don't have to like the why. You don't have to like it. My wife tells me things all the time. And when she tells me things initially, I'm a guy. I don't like what she just told me. Robbie, this is good for your marriage. I don't like what she just told me. But what I do, consciously, I listen to her even though I don't like her words, and I back off from the guy inside of me that wants to, rebut her. I don't do that no more. I've got a great marriage, 35 years. I don't do that no more. I listen to her. And more times than not, when I back out consciously, not physically, I back out consciously from what she just told me, and I think about it I mull over it for a little bit. I then realize, dang, she's right again. She is flat right again. And that's the truth, because I make it safe for her. I make it safe for her to speak up and challenge my status quo, my ego, right? All right. Do you guys have any questions at all? Good? All right. You guys are welcome to get a hat now. Okay? You guys are welcome. Okay?